Welcome pre-cal students to the homework help video. Here's the assignment right here in front of you. Let's go ahead and get started. Number 27. Actually, the first 5 problems are going to be graphing rational functions. And so in your notes I've given you 3 steps. Step 1 is to find the all of the asymptotes. So in order to find the vertical asymptotes, we take our denominator and we set it equal to 0, x equals 0, and we solve. There's really nothing to solve. Obviously x equals 0, so we have a vertical asymptote at 0. Okay, moving on to horizontal asymptotes. Even though there's no x up here, you can really look at it like this: x to the 0 power. So the degree in the numerator is lower than the degree in the denominator. Thus we have a horizontal asymptote at y equals 0. Now remember, you will never have a horizontal asymptote and a slant asymptote at the same time. Okay, so if we have a horizontal asymptote, there's no slant asymptote. We only have slant asymptotes when the degree in the numerator is exactly 1 higher than the degree of the denominator. Okay, and obviously that's not the case. Okay, moving on. We've done step 1. We have found all of our asymptotes. Step 2 says find the x and y intercepts. Well, in order to find the y-intercept, we put a 0 in for x. Well, if we put a 0 in for x, we get 1 over 0. That's undefined. So there is no y-intercept. Now, remember how I taught you guys the shortcut. If you want to find the x-intercept, instead of putting 0 in for y like you usually do, there's a faster way to do this. You take the numerator, which is 1, and you set it equal to 0. Well, 1 equals 0 doesn't do anything for you, students. I mean, there's nothing you can do with that. There's no x. You can't solve it. So there is no x-intercept. So there's no x-intercept and there's no y-intercept, which really makes sense because the x-axis is your horizontal asymptote and the y-axis is your vertical asymptote. So the only thing left to do is to plot some points to the left of your vertical asymptote and then plot some points to the right and see what happens. Okay, so I'm going to start off with -1, -2, -3, and -4. All right, I already have this function typed into my graphing calculator, and so I'm going to go ahead and look at my table of values. For -1, we'll start with -4. For -4, I'm getting a -1/4. For -3, it's a -1/3. For -2, I'm getting a -1/2. And then for -1, I'm getting -1. So here we go. -1 is -1, and then -2 is a half, then -3 is a third. You can see it's getting closer and closer. It's curving, getting closer and closer to your horizontal asymptote, but never touching it. Now, let's get really close to this x, to this vertical asymptote. Let's put in 0.1, okay? 0.1. When you put in 0.1, or I should have put in -0.1, I apologize. Let's fix that real quick. When you put in -0.1, you're getting out -10. So at -0.1, it shoots way down to -10. So we're pretty much assured the graph is looking something like this. Now let's plot some points to the right of my asymptote. Let's try 1, 2, 3, and 4. You're probably going to get out a +1, a +1/2, a +3, or a +1/3, and a +1/4. In fact, actually you are. And so 1 would be at 1, 2 would give you out a half, and then 3 a little closer, and then 4 a little closer. So obviously the graph is curving down like this, hitting here and getting closer and closer to the x-axis. Now let's put in 0.1. If you do, you get out 10. So I know it's shooting way up here, getting closer and closer to the vertical asymptote, but never touching it. So there we go. Problem number 1 done. Moving on to the second problem in your graphs. Okay, step 1, find all of your asymptotes. So we take our denominator, x plus 2, set it equal to 0, and solve. And we have a vertical asymptote at -2. Okay, vertical asymptote at -2. Now let's check for horizontal asymptotes. Notice I have a degree of 1 and a degree of 1. Whenever your degrees are the same in the numerator and denominator, you have a horizontal asymptote at lead coefficient over lead coefficient. Well, your lead coefficient is 1, your lead coefficient is 1, so your horizontal asymptote is 1 over 1, which is really 1. So we have a horizontal asymptote at 1. There are no slant asymptotes because the degree of the numerator is not exactly 1 more than the denominator. So we're going to move on now to step 2. Let's find the y-intercept. Let's put a 0 in for x, a 0 in for x. You'll get negative 1 over 2, which is negative 1/2. So the y-intercept is negative 1/2. Now let's find the x-intercept by taking the numerator and setting it equal to 0. So x minus 1 equals 0. Bring the 1 over and you get 1. So the x-intercept is 1. Okay, that's pretty helpful. And now let's go ahead and plot some points to the left and to the right of your asymptote. Let's start off with negative 3, negative 4, negative 5. So negative 3, negative 4, negative 5. And let me quickly change the functions here in my calculator. And let's see what we have here. Let's see what negative 3 is for. Negative 2, or negative 4 is 2.5. And negative 5 is 2. So at negative 3, 1, 2, 3, 4, I'm up here at 4. And then negative 4, I'm at 2.5. And then at negative 5, I'm at 2. I'm assuming if you go ahead and put in negative 6, negative 7, negative 8, you're going to see it's going to hit here and continue getting closer and closer to the horizontal asymptote. Now, I'm also going to put in negative 2.1 just to see what I get out. And at negative 2.1, you're getting out 31. So it's shooting way up here. So we know it's going to get closer and closer to the vertical asymptote and never touch. Now, let's go to the right of your vertical asymptote. If you put a negative 1 in, that's fine. You don't need to put a 0 in because you know at 0 you're at negative 1/2 already, and you know at 1 you're at 0. I'm going to go ahead and put in 2 and 3 also. So going to my table of values, for a negative 1 I'm getting out a negative 2, and for 2 I'm going to get out a 0.25 or 1/4, and for 3 I'm going to get out 0.4. Alright, so at negative 1, I'm at negative 2. So it looks like the graph's going to hit here, go like this, curve, hit here. At 2, I'm at 1/4, and 3, I'm at 0.4. So it's hitting, it's curving, and it's getting closer and closer to the horizontal asymptote. Now, if I put in, trust me, if I put in negative 1.9, think about it, here's 0 on the x-axis, negative 1 on the x-axis, negative 1.9. If I put in negative 1.9, it's going to shoot way down like this, okay? So there we go. Graph number 2 accomplished. Let's move on to number 3. Okay, let's find the asymptotes. Your vertical asymptote would be, take the denominator, set it equal to 0. And of course, let me show you something. X plus 1 to the third power just means you have x plus 1 written 3 times. Well, guys, I mean, do you really need to take x plus 1, x plus 1, x plus 1, and take each one and set it equal to 0? There's really no need to do that, okay? So it's obvious, if you bring the 1 over and make it negative 1, it's obvious we're going to have a vertical asymptote at negative 1. So there we go, there's the vertical asymptote. Now, the horizontal asymptote, please be careful here, students, okay? X plus 1 to the third power. We've learned shortcuts on this. In fact, last week we looked at this. You don't need to do all the multiplication to see what the degree is. Just take your first group times your first group, and the highest power you would get is x squared. Then take x squared times this group here. The highest power you would get would be x cubed. So the degree of your denominator is x to the third power. The degree of your numerator is x to the 1 power. So whenever the numerator is smaller than the denominator, you have a horizontal asymptote at y equals 0. Okay, so here's your horizontal asymptote, and there are no slant asymptotes. So there we go. I mean, this is pretty fast. Now let's find the y-intercept by putting a 0 in for x, 0 in for x right here, and a 0 in for x here. 0 minus 3 is negative 3. 0 plus 1 is 1. 1 to the third power is 1. So I'm getting out negative 3 for my y-intercept, negative 3. Now let's go ahead and find the x-intercept. We do that by taking the numerator and setting it equal to 0. So it looks like the x-intercept will be at positive 3. Positive 3. And now we're ready to plot some points. So let me grab my graphing calculator real quick and switch over to another function. Okay, let's plot some values or evaluate some x values going to the left of my vertical asymptote. Negative 2, negative 3, negative 4, I guess maybe negative 5 also. Let's see what we have here. Negative 5 is 0.125, negative 4 is 0.26, negative 3 is 0.75, negative 2 is 5. So here we go. Negative 2, 1, 2, 3, 4, 5. And then negative 3 is 3/4. Negative 4 is here. Negative 5 is about right here. So as you can see, it's hitting here, it's getting closer to the horizontal asymptote, then it's shooting up quickly. And just trust me, if you put in a number real close to this vertical asymptote, like negative 1.1, it's going to be really high. Okay, it's going to shoot up here. Now, let's plot or evaluate values to the right of the vertical asymptote. So I don't need to put in 0. I know 0 is already negative 3. I'll put a 1 in, a 2 in. I know 3 is already at 0, and I guess I'll put a 4 in too. So here we go. Let's see what happens here. Let's start with 1. 1 gives me negative 1/4. 2 gives me negative 0.037. 3 would give me an actual 0, and 4 would give me 0.008. Alright, so let's kind of see what this is doing here. 0 is at negative 3. By the way, trust me, if I put in a value really close to this asymptote, like negative 0.9, I would get out negative 3,900. It's going to shoot way down here. So I know it's going to shoot way down here. And then let's see, at negative 1, I'm at negative 1/4. And then at negative 2, I'm getting closer. Then it actually hits. So it hits here, hits here, hits here. And then at 4, it goes above barely. So I think it'd be very wise to go ahead and put in 5, 6, and 7 and just kind of see what this thing is doing, okay? And it looks like to me, yep, as you put in 5, 6, and 7, it hits and it goes up just a hair, and then it comes back down and levels out and gets closer and closer and closer to the horizontal asymptote. Okay, so I didn't give you these numbers right here, but on my graphing calculator, they're just getting really closer and closer to 0. So they went up a little bit to 0.008 and 0.009, then start going back down again. Okay, so problem number 3 solved. Let's go on to your 4th graphing problem. Okay, here we go. Let's find first of all your vertical asymptotes. So let's take our denominator and set it equal to 0. X squared minus 5x minus 14. Let's go ahead and factor that. You would have x negative 7, x positive 2. And for this parentheses, we would have a positive 7. For this parentheses, I guess I should set it equal to 0. There we go. For this parentheses, a negative 2. So I'm going to have a vertical asymptote at 7. 1, 2, 3, 4, 5, 6, 7. We're going to run out of room, I believe. So because that's going to happen, let's go ahead and slide this down. And let's do our work up here. And here we go. Okay, we have a vertical asymptote at positive 7. And a vertical asymptote at negative 2. negative 2. There we go. Okay, moving on. Now, number 3, or step number, now we got to find horizontal, vertical asymptotes. And so for your vertical asymptotes, or for horizontal asymptotes, there are none. Your degree is 1 higher than the denominator, so we do not have a horizontal asymptote. However, unfortunately, we are going to have to very quickly do long division, okay? Because whenever your degree in your numerator is 1 higher than your denominator, you have a slant asymptote and you have to find it. So here we go. X squared goes into x cubed x times. Do your multiplication and you will get this right here. All right, change all your signs and add. These will cancel. 7x squared minus x. Now, x squared goes into 7x squared 7 times. 7 times x squared, 7x squared. 7 times negative 5, negative 35x. And then 7 times 14. We really don't care what this is, students. You're going to get negative 98. Put a 0 here. It really doesn't matter. When you change your signs and add, you're going to get 34x. You can't divide any further. There's no way an x squared goes into an x, so we don't care about the remainder. All that we care about is this. So remember, you take your quotient and you set it equal to y. So there's your slant asymptote. Okay, y equals x plus 7. Now what we have to do is we have to plot points and graph that slant asymptote. Let's do that very quickly here. Let's put in a 0, a 1, and a 2. So if we put in 0, we're at 7. Put in a 1, we're at 8. Put in a 2, we're at 9. So 1, 2, 3, 4, 5, 6, 7. So 0, 7, 1, 8, 2, 9. So here is your slant asymptote. Okay? And here's your vertical asymptote continuing upward. All right? And we might have to shrink this down a little bit here too. We'll see. Okay, continuing on. Now, let's go ahead and find the x and the y-intercepts. If you put an x in everywhere, if you put a 0 in everywhere there's an x, you would have a 0 here, a 0 here, a 0 here, a 0, a 0. You would end up with 0 over negative 14. So the y-intercept is obviously going to be at 0. Now, for the x-intercept, you take the numerator and you set it equal to 0. And that will give you the x-intercepts. Okay, well, first of all, we can factor out an x. And so when we do that, we're left with x squared plus 2x minus 15. Then we have a trinomial here we can factor. And the factorization of this trinomial would be x plus 5, x minus 3. Now for this group here, I would get a 0. For this group here, a negative 5. For this group here, a positive 3. So it looks like I have 3 x-intercepts. I know I have one here already. And then 1, 2, 3, 4, 5, negative 5. And then 1, 2, 3. I have one here. Okay? And then you know also we're going to have to plot some points to the right of your vertical asymptote too. Okay, we did it. Now we're on to step 3. I'll try to do this as quickly as possible to save time. Let's see what happens here. First of all, I have a vertical asymptote at negative 2, so I'm very quickly going to put in negative 3, negative 4. We already know negative 5 is 0, and a negative 6, okay? And let's see what we get out. Let me quickly go to my calculator and get the right function loaded up here. And here we go. All right, let's take a look here at negative 3. I will have 3.6. Negative 4 will give me 1.3. Negative 5 is 0. And negative 6 is negative 1. I rounded that. And let's go ahead and put a negative 7 in real quick. Negative 7 is a negative 2. And negative 8 is a negative 3. I rounded that. So very quickly, let's plot those points. So at negative 3, I'm at 3.6, about right here. At negative 4, I'm at 1.3, which is about right here. And then here and then -6 is -1, -7 is -2, and -8 is -3. So it looks like to me we're getting something that goes probably down like this here. And the only thing is, students, now one thing I noticed here, students, is I started to plot these green points right here, and let me go ahead and erase those just for a second. I really feel like I probably should have done a better job of getting your slant asymptote a little more accurate, so I'm going to do that very quickly here. And this is a good problem because it gives you an example also of, remember how I've mentioned that horizontal asymptotes can be crossed. Vertical asymptotes will never be crossed. Occasionally horizontal, and we've never had this scenario yet, but also occasionally slant asymptotes too. But they're still really good boundaries, just like your horizontal asymptotes. Okay, I'm going to continue this up here. Now, I paused the video because I was doing some research and kind of checking out what the other points were going to do. And it saves you time. That way the video is not running. Now, okay, I have these points here. If you'll look, when I plot these points, look how close I am to the slant asymptote. Please watch this carefully. -3 is at -3.6, right beneath the slant asymptote. -4 is at 1.3, and then -5 is at 0, and then -6, -1, -7, -2. I'm rounding those, but it looks like, you see, it's hitting here and it's curving a little, and then if you put in -2.1, I think I got out 35. It's way up here, so it's getting closer and closer to your vertical asymptote but never crossing it. And even though it crossed the slant asymptote, do you see how it's starting to run parallel to it? So your slant asymptote is still a really, really good help. It's a really good boundary, okay? Now, I'm going to plot some points between my two asymptotes, like -1. I already know 0 is 0. We'll put a 1 in, I'll put a 2 in, don't need to put a 3 in, I know 3 is 0, and a 4 and a 5 and a 6. With a table of values, that takes hardly no time at all. -1 gives me out a -2, 1 would give me out a 0.7, 2 would give me out a 0.7 also. Actually 1 was 0.666. 3 of course is a 0, 4 will give me out a -2, 5 will give me out a -7, and 6 will be a -24, 25. I'm rounding those, of course. So -1 is at -2. Then we have this here. 1 would be at 0.7. And then 2 would be about the same, kind of flattens out there. And then it starts going back down. Here we'd be at -2. So looks like we have a little parabolic shape, a parabola. So it's going to come down again. We're just sketching it. It's going to get closer to this asymptote over here a lot faster than this one over here. And then trust me, students, just to save time, if you put in 7.1, barely go past the asymptote, you get out 387. So I know it's way up here. And then if we plotted points, I'm not going to take time to do it. If we did 8, 9, 10, 11, 12, you're getting numbers up here in the 20s. And if you plotted them meticulously, it would come down like this and then curve a little right here and then run not parallel, but getting closer and closer to the slant asymptote. Okay, so there we go. This was a pretty good one, a very challenging one, so it was good for you guys. Okay, number 67, and we'll be finished with the graphing. So one more. Okay, here we go. We know step 1 is to find your asymptote, so I'm going to take the denominator and set it equal to 0. We're going to factor this, and we will get x minus 2, x plus 1. And so my asymptotes will be at +2 and -1. So here's my +1 vertical asymptote. And then here is my -1. Looks like I need to learn how to draw straight lines. All right, now let's take a look at my horizontal asymptotes. Whenever the numerator degree equals the denominator degree, your horizontal asymptote is at 1 over 1. 1 over 1. So your horizontal asymptote will be at 1. There we go. All right, and now let's see here. Next, let's find our y-intercept by putting 0 in for x. So put a 0 here, a 0 here, a 0 here. You'll get 0 over -2. So your y-intercept will be at 0. Now let's find our x-intercept by taking the numerator and setting it equal to 0. And of course, take the square root of both sides, you get 0. So we have an x-intercept at 0 also. All right? Now lastly, we're going to plot values or evaluate x values in between my two asymptotes. Okay, so let's go ahead and get ready to do that. I'm going to put this. I have an asymptote of -1, so I'm going to put in numbers like -2, -3, -4, -5, and let's kind of see what happens here. Okay, here we go. Let's see. -2 will give you a 1. -3 will give you a 0.9. This will be 0.88. This will be 0.89. And then back up. I'm going to keep going here. -6 is 0.9. And then -7 is 0.9 again. So let's go ahead and get an idea of what we're doing. -2 would be right at 1. Okay, so this horizontal asymptote will get crossed. -3 will be at 0.9, -4, 0.8. And look, it does a little dip here. It comes down here. -1, 2, 3. -4 is 0.8, and then, boy, I wish we'd quit doing that. Like right there, and then it goes back up. So there's a little lowering there. So it looks like to me it curves down, curves back up, hits here, and then levels out. Now if you put in -1.1, it's going to go up to 3, about right here. So it does cross the horizontal asymptote, which happens sometimes, and then it's getting closer and closer to your vertical asymptote. Now let's plot some values in between your two asymptotes. We already know 0 is 0. Let's put in 1 and see what we get out. And if we put a 1 in, we will get out a -0.5, so -1/2. So 0 is 0, 1 is -1/2. So I'm going to suggest that we get really close to this asymptote. I'm going to put in -0.9, -0.9. And if you do that, you get out -3. So -0.9 will be down here at -3. And then I'm going to suggest we put in 1.9 and see what we get out. And 1.9 gives me out a -12, so way down here. So it looks like we're going to have a little bit of a parabolic shaped curve. It's going to come up, hit here, and then start curving its way back down. Again, we're just sketching it. Doesn't have to be perfect, okay? And now let's go ahead and plot some points to the right of your asymptote. We're going to put in 3, 4, 5, and 6. So here we go. If you put in a 3, you will get out 2.25. If you put in a 4, you will get out 1.6. If you put in a 5, you will get out a 1.4, and a 6 gives you out a 1.3. So we go over 3, we go up 2.25, we go over another one, that's 1.6, go over here, it's 1.4. So we kind of get the idea. It's coming down, hitting here, and getting closer and closer to the horizontal. And then if you put in 2.1, just out of curiosity to see what would happen, you're going to get out a really big number of 14. So we know it's going up like this and curving up, okay? So we've done pretty well. We only have 2 problems left, and the last 2 problems are not graphing, okay? So that's how you would graph that rational function, and hopefully that makes a little bit of sense. Okay, guys? Let's look at our last 2 problems. I wanted to throw some problems at you to make you think and go backwards. Okay, so let's see if we can do that. They want us to write, if you'll read the instructions, it says write a rational function that has this characteristic. Okay, I paused the video because I wanted to turn to page 317 and read the directions exactly out of the book. Find a rational function that satisfies the given conditions. Answers may vary, but try to give the simplest answer possible. Okay, they want to have vertical asymptotes of -4 and 5. Now think about it. That means in your rational function, your denominator has to have x plus 4 for one of its linear factors, and also x minus 5. Doesn't that make sense? Remember, how do you find vertical asymptotes? You take the denominator and you set it equal to 0 and solve. So if I took this denominator right here and set it equal to 0 and solved, I would get -4 and 5. So I'm pretty good now, guys. The only thing that comes into question is, am I allowed to have horizontal asymptotes? Am I not allowed to? And that's a really good question, and I don't think the instructions were very they weren't very specific on that. Well, first of all, let me go ahead and multiply this out. So your denominator would be this right here. Now, here's what I think you should do. If you make the degree more than one higher, in other words, don't put x cubed, don't do that. Put an x to the 4th or an x to the 5th or an x to the 6th. If you do that, then you're pretty safe, because think about it. You have your two vertical asymptotes. If I said, students, find the vertical asymptotes for this function, you would take the denominator, set it equal to 0 and solve, and you would get these right here. If I said, what's the horizontal asymptote, you would say none, because the degree is higher in the numerator. And if I said, hey, what's the slant asymptote, you would say what? None, because the degree is not exactly one higher than the denominator. So I would not put a 3 here, because then you would have a slant asymptote, and it did not ask you to find a slant asymptote. So the safe answer is to simply put this right here. This function here has no slant asymptotes, no horizontal asymptotes, and it has vertical asymptotes at these two numbers right here. Okay, so that's a good thinking problem. Let's take a look at one more, and then we'll be finished with the homework assignment. All right. Okay, students, well, that's problem to do. Now, this one here is a really tough problem. I'm not sure if I'd give you one of these on a test or a quiz. I might. It's really, really tough, so just bear with me and think this through. I think the vertical asymptotes are the easiest to deal with, because we know if I want vertical asymptotes of -4 and 5, then I want to have an x plus 4 in my denominator and an x minus 5. I hope you see that's pretty much common sense, because if you were to take this denominator right now and set it equal to 0 and solve, you would get -4 and +5, and that's what you want. Vertical asymptotes always come from the denominator. Now here's where it gets a little sketchy, kind of difficult. Your horizontal asymptote is at 3/2. Now remember, what that means is your degree up top has to be the same as your degree in the bottom. Okay, and it means your lead coefficient has to be a 3, and your lead coefficient down here has to be a 2. Now, this is not going to be easy to see, but remember something here. This is really going to be hard to understand, but listen carefully. Your degree down here right now, let me get rid of this 3 and 2. Your degree down here right now is a second degree. If you were to multiply this out right here, you would get x squared minus x minus 20. So right now your denominator is a second degree. That means you must have a second degree up here also. You say, why, Mr. Earhart? Because if you have a horizontal asymptote at 3/2, remember, if the horizontal asymptote is not at 0, then that means the only other way to have a horizontal asymptote is when your degree in the numerator is the same as the degree in the denominator. So I must have a degree up here that's the same as the degree down here. Well, we all see how I have a second degree down here. So I know up here I'm going to want an x squared. So I'm going to put 2 parentheses. Now, you want to have an x-intercept of -2. And so if you want to have an x-intercept of -2, remember how we find x-intercepts? Let's back up. I told you this is a hard problem, okay? In order to find vertical asymptotes, you take the denominator and set it equal to 0. So I took these two numbers here and put them back in, changed their signs. Now, in order to find the x-intercept, you take the numerator and you set it equal to 0 and solve. That's how you find the x-intercepts. So I'm going to say I only want one x-intercept at -2. So I'm going to put x plus 2 twice. Now the reason I'm going to do that, think about it guys, if I take this numerator right here and set it equal to 0, what will I get for my answer? I would get -2 for both of these. So I have an x-intercept at -2. Now, this is really falling together nicely because look, if I have a degree of 2 up here and degree of 2 here, then the only thing left to do to get a horizontal asymptote at 3/2 is simply put a 3 here and a 2 here. Let me show you what happens. Watch carefully. If I take this parentheses here times this parentheses here, I will get x squared plus 4x plus 4. Now take your 3 and multiply it through, and you will get 3x squared plus 12x plus 12. And that's definitely what I'm looking for in the numerator. Okay, so I'm going to slide that down in just a second. Now, let's simplify the denominator here. I'm going to slide it down just a little, give me some space, and let's simplify this. If I were to multiply these two parentheses together, I would get x squared minus x minus 20. Now take your 2 and multiply it through, and you would get 2x squared minus 2x minus 40. 2x squared minus 2x minus 40. Now, I know you're ready to get the homework assignment over with, but let me say this to you very quickly. If I wanted to check this on a test or a quiz and make sure that I had it correct, all that I would have to do is very quickly take the denominator, set it equal to 0, and solve. Trust me, if I did that, I would get these two numbers here for my vertical asymptotes. Next, I would check my horizontal asymptotes. Well, the degree is 2, the degree is 2, so your horizontal asymptote is lead coefficient over lead coefficient, 3 over 2, and that's what I have. And then if I want to check my x-intercepts, remember you take the numerator, set it equal to 0, and solve. And trust me, if you did that, you would get -2 for your answer. So this function here totally satisfies what we're trying to accomplish. Okay, I hope this homework help video has been a help to you. Call or email if you have any questions.